I work at Fidzai, and we are building software for fighting fraud, and mostly our customers are big financial institutions. And what I've been seeing is that there is always a big bias on how big financial institutions work, and in general that they don't have any type of innovation. So what I wanted today is to give a little bit of a sneak peek of how do we innovate at Fidzai, and mostly not only focus on the big innovation types, but also on how do you innovate on a daily basis. So who here thinks that the enterprise software is boring? Anyone? Don't be shy, otherwise it will be very easy for me to convince you otherwise. All right, there is no one. So, as I was saying, the first thing when you think about innovation, you think about the future. You think about the scientific research. How do you disrupt the market? How do you use the latest technology? And how do you invent something new? However, it's very common that we, on our daily basis, and especially on tech companies, where there is always this type of focus on the big picture of innovation, very easily we can forget that other things also need innovation. So for us, innovation is about changing the status quo of how do you think on a daily basis. And in fact, it's one thing that we have been trying to work at our company is to understand how do our engineers see innovation, and we got pretty interesting results. So that's why I decided to share this talk, and I wanted to mostly focus on how do we innovate on a daily basis and on the small things, and those things probably will impact much more your daily life if you are working at a tech company than the new products that you are bringing. So what's enterprise software? It seems like a big buzzword. It's mostly software built for solving problems of organizations and not solving problems of individual users. Of course, everyone and organizations are built by users, but you are not trying to solve and optimize for a problem of a user itself. You are trying to optimize for a problem of the company, all right? So what does that mean? It means a lot of things. And in fact, for developing software for these large corporations, and especially financial industry, it means that you need to worry about a lot of things that might impact your way to innovate. So let's look at a few of them just to level set. So first one, and this is always the main one, is the quality and the stability of your software. Your customers will be paying you hundreds or even millions of dollars, and you are putting software where their businesses rely on it. And in general, the money that they pay is in fact even a fraction of the money that they are making. So there are a lot of SLAs and penalties if your products don't perform as expected. And one of the things in this industry is that you are not deploying mostly on the cloud. There are very strict rules about how you deploy software, how do you change things. So there is no such thing as let's just upload this quick patch that in general takes a couple of months to roll out. So if you are not really sure that your quality is top-notch, you might be on a really bad place. So quality for the development processes is very time-consuming. The second one always is security and compliance. As we usually say, the customer's data is much bigger than ourselves. So if we compromise in any way about security, we really don't want to be in the headlines of a data security breach. And on a daily basis, FeedSci deals with hundreds of millions of users' data, and that's very, very important for us. So protecting it is always a priority. So you might imagine on the way that we build features, the processes, the operations, the compliance. This is always a barrier to the way that we innovate and we build software. For example, even in our development process, we need to be very careful. We need to train our developers about secure development practices. We use extensively code reviews, static analysis, penetration testing, and a few other things on the software development process to make sure that our software is in fact secure. Then I would say to fill the triology, there is always the performance. If you are heading for the largest customers in this sector, and we have the luck of having some of the largest customers in the financial sector, you are really dealing with very large-scale systems where, for example, it's very normal that our system cannot even degrade 1 second per day. This means basically 9/5 percentile of performance, and I will have some results and some numbers to share in a few slides next. One thing that is also for us very challenging in terms of innovation is that nowadays everyone talks about continuous delivery, continuous improvement, ship fast your software. But in our situation, it's very hard to do that because we are trying to release every month, but then our customers say, oh, I can at most upgrade twice a year, most generally once a year. So there is a very fine-grained trade-off between how do you release often and how do you get feedback. If you only have customers adopting the software once a year, there is very hard to get feedback and to evolve and innovate in your products. There is a slow cycle, but in the end, we need to make sure that we go over it. Customer focus is something that is not different in the enterprise software and in the other types of software that are out there. The main difference is that when you are dealing with a very large customer that has a lot of impact in your revenue, that customer expects to be listened very carefully. It's always expecting customization, is expecting to change your roadmap and have the power to do it. And very often, the requests that those customers have are important, but they are not focusing on innovation and be ahead of the market. They are trying just to solve their local pains. So the problem is, okay, we have all of these things. I forgot one, sorry. The last one is compatibility. One of the things that is very common, or one of the phrases that is very common from Facebook and Mark Zuckerberg is initially it was move fast, break things. After a few years, he adjusted this phrase and he moved it to a not as sexy one, which is move fast with stable infrastructure. It's not as catchy, but it's the way that he adjusted it because it was needed for Facebook. So One of the challenges that we have that is also related with the release cycles and how the customers get the software is the compatibility and the legacy that you need to maintain. So it's very important that you focus on being compatible because this will help your customers to adopt new software, adopt new versions, and of course, once again, this has some impact. You cannot just break things because it will be against you, and your customers will retain on older versions. So as I was saying, with all of these characteristics, how is it possible to innovate? And in fact, it's very challenging to focus on innovation with all of these restrictions and constraints. So my goal with this talk is now to look at a few processes and a few things that we have done at Feedzai since we started, and basically to show you that this is possible. Enterprise software, it's also interesting, and in fact, because also deals with, of course, a lot of money. It can also, if you really use it for a good thing, you can really build cool stuff. So the first thing is just to give you a landscape of our technology adoption. I just choose the last 5 years. Back in 2002, we started our user interface in a single-page application with Backbone.js and Require.js. And then we moved, on the backend side and processing, we started adopting Hadoop, then Cassandra, Java 1.7 and Java 1.8. And notice that I've selected to put here not the technologies that we try, but the technologies that we are putting in production. So when you are, the dates that I'm here, it's dates where we put this type of technologies in production in some of the largest financial institutions in the world. For example, especially with Cassandra, I remember that back in 2014, there were 3 major financial institutions in the United States that we have deployed in production, and they never had any deployment of Cassandra in their systems. So just from a compliance team's perspective, support operations, we are a small startup compared with these type of corporations. We are pushing them to get new technology, and this is a good way where startups can really push on the big corporations and let them innovate. On 2014, we moved to our distributed architecture, so we adopted RabbitMQ and Zookeeper. One of the interesting things, for example, is that at the time we were already benchmarking and testing Kafka, but in that situation, we really demonstrated for ourselves, we engaged with the community, and that Rabbit was much more fast for us, with lower latencies, and was much suitable for our needs. 2015, Docker, we'll talk about it in a few slides. Then we have revamped our user interface and started new products with React.js and Webpack. Then we moved to Spark as well. While we were in Hadoop with MapReduce jobs, we moved now to Spark. And last year, by the end of the year, we launched our cloud offering with AWS. So one of the things that we generally struggle with our engineers is how do we adopt technology? In the end, we have customers that really need to sustain their businesses and mission-critical systems that rely on this technology. So you really need to be careful on how you select that technology. But mostly, recent technology is very important for us. It allows us to build better products, to develop faster, and to leverage mostly the open source community that is contributing for us to advance. So our main concerns in regarding to the adoption of new technology at FeedZai is first, does it solve your problem, or is just something that some of our engineers or even the community is really excited about? There is space for trying that technology. There is space even inside our company to try it and experiment, but that shouldn't be a driver for selecting a technology to put your production workloads. So the first thing is, does it really solve your problem? The second one is maturity and stability of the technology. It's not about, is it a technology with 10 years old? It's about, is it really active? Does it have has a lot of contributors? What's the bug volume? How many supporters and backers of this technology are? We are very curious about the technologies that the big tech companies use. And they are creators of this technology very often. But in the end, do you want to be in the hands of, let's imagine, Google or Facebook, if they are the only ones using that technology, even that it's at very large scale? So we are also very careful about that. Look at, is it a top-level Apache project that has the support of the Apache Foundation? And please make sure that the technology is already being adopted. In general, it's very common that you get this after 2-3 years of the technology to become popular. And lastly, but not less important, in our space, is the support. Is there anyone doing support on this, and especially if there is any commercial company supporting it? Hadoop, you have Hortonworks and Cloudera. Cassandra, you have Datastax. There are a lot of companies that have a business model of making sure that they continue to evolve these technologies. So this is also important, mostly not for us that we are incorporating it, but for our customers that are depending on these technologies as well. So first slide of fun facts. This is real information. It was taken from August, from one of our customers. In this single customer, we have processed 700 million transactions in August. We had a peak volume of 380 transactions per second, 3,800 transactions per second. And this means that you receive a transaction, you are going to clean it up. You need to look at historical data up to 6 months. You build all the features for your machine learning model. You score it, you apply some rules, and respond back to the customer. So we have a median latency of 7 milliseconds. We are going to disks. As you all know, most of the disks, if you are dealing with a lot of volume and you don't choose SSD drives, you are already dead if you want to get to these type of latencies. But I would say most impressive in our case, in dealing with this case personally, is we are achieving 5 nines percentile of 150 milliseconds. What does this mean? It means that in these 700 million transactions during August, only 7,000 were above 150 milliseconds. This means that if this happens at the peak time, which is in general where it happens because we are talking about performance, it means 2 seconds in the full month. Usually, if you just SSH to the machines, you get a glitch on network. If there is anything on the data center, you are basically violating the SLA. So this is very cool and exciting, at least for the ones that deal with these type of problems. But once again, how do you move fast if you really need to make sure that these SLAs get fulfilled? And mostly if these SLAs, if they are violated, they have significantly large financial penalties. I don't try to scare the engineers, but if we fail one of these SLAs in one of the months, it's the cost of the full team during the full year. So we really need to make sure that once we push software to our customers, it's really rock solid. So with all of these very strict performance requirements, how do we manage to solve them first, and then how do we keep pushing forward and keep innovating? So the first thing that we started to do, and this year we made it like official, but we set up an expert area for performance engineering. This year we firstly dedicated resources 100% just to performance engineering, and what they are doing is they are training and supporting the development teams how to make sure that on a daily basis they don't commit code that is slow. And this is very easy to do, to make slow code even without knowing that you are doing it. So creating all of these best practices, training the teams, giving some of the talks. Of course, they are doing performance tuning on a daily basis, especially with our largest customers. And they also work a lot on benchmarking processes in tooling. Tooling is essential for us because when you are dealing with this level of SLAs, you cannot just test something for 15 minutes or 1 hour. Even 24 hours, you can have of a benchmark session. It's very easy that you just get anomalies. There are statistic anomalies. So it's very important that we fully automate all of these processes to reduce the impact and then the speed on the development cycle. So moving to another topic, which is quality assurance. This is one of the topics that since the beginning we were very keen on making sure that we don't want test monkeys, just to be very straight. We believe that quality assurance is an area of expertise. So at Feedzai, we have software engineers in test. What this means is you really need to be a software engineer that is applying your skills to make sure the quality of the software is top level. This means first that we want to make sure that we have independent validation. You can be the best software engineer in the world, but you will be biased testing your software. It means that they spend a lot of time on automation. Once again, we don't want manual work, and it's very important for us to scale our teams. They also optimize a lot the processes. One of the things where teams get very slow is when you don't have the efficient processes to support the development. Build tools, and last but not least, making sure that they push the developers. They need to question the developers. They need to make sure that the engineers are building the right software. So at Feedzai, the teams that say that we can release software should not be the engineers or the developers. It should be our software engineers in test. So one example that I choose to demonstrate this, and I would have a few others. We already had some talks about this. I chose this because of two things. First, because this was not even identified by the development team. This was one of our software engineers in test that really decided this doesn't make sense to continue to validate a distributed system without proper tooling. So testing distributed systems is generally hard, complex, and time-consuming. We are talking about having a lot of components to orchestrate, and mostly because, once again, we are in an enterprise software world, there is no such thing as one architecture. You have a lot of configurations that you need to test. So at the time, the team decided that they wanted to do what they called the system test framework. And what this means is they wanted to write tests, like unit tests, that could basically test a distributed infrastructure. So they pick up on Docker, and very easily, any developer, any software engineering test can write a test like it was a unit test, but you are behind the scenes setting up 10, 15 Docker containers. They are all configured automatically, and it's very easy to develop this type of tests. Currently, this is and assumed by the engineering team, the software development team, and the software engineering and test team, as the best tool that the team has to validate the quality of our software. And now that they have built this, new challenges arise, and which will need and are currently needing their skills of software engineering, and not just I want to validate code that other engineers have built. So we are currently, this means in practice that this team has to manage a cluster of 1,500 cores of processing, 6 terabytes of memory. It's very normal that one regression suite needs to spin up about 6,000 containers just to run the regression suite. So now they have a problem of operations. The software is much more stable, but it's on them to make sure that this infrastructure doesn't slow down the engineers. One thing that is very common, especially if you are developing a product for 5, 10 years, is technical debt. So the way that we look at it is deal with it or just carry the weight of the technical debt. So you need to embrace how do you deal with this, how do you innovate, and how do you take this leverage to innovate on your products. So one of the things that we do or in a constant basis is monitor the technology evolution. As you probably seen in the technology adoption, there were at least 2 groups of technologies that we have basically revamped after 3 years. First, we started with on the user interface front with Backbone, and after 3 years, we moved to React. On Hadoop, after 3 years, we moved to Spark. And this is this process of identifying new technologies and how can they power up and boost our current functionalities. So if you deal with technology depth or technical depth and legacy as a product, it's very easy to commit the product teams to improve your product, change technologies, and as a result, you are basically just removing this technical depth and you are re-implementing your functionalities, making them better and making them much more suitable for your customers. Rewriting code is not the solution for everything, but it really helps you to clean up old features. It really helps you removing problems in your code base. And especially, one of the things that it's also very good is that you will be able to train new software engineers in the majority of your code base. One of the last things that I wanted to talk about is about the processes. We cannot innovate if we don't bring new processes and if we don't leverage and we don't push and are not demanding with our processes. So you have a product, you have people, in between you need to merge them with processes. So I selected a few of them that I consider that we have changed, and especially that I would say that most of these were adopted very early at Fidzai compared with the industry. So on the development side, we really believe in planning ahead. This doesn't mean waterfall approach. This means that you want that engineers really think. They look at the engineering part and not as the coding part. Coding is just a way of making that piece of engineering come to life. So really making sure that you have good technical designs and specifications are a way that we have seen constantly that helps our innovation, because we don't lose a lot of time on fixing architectural errors because we really thought on them. The other part is do it together. I think nowadays this is becoming the standard. We still see in our recruiting process a lot of engineers saying that they really value code reviews and pair programming. And this is something that is not yet a standard in the industry. I think it's becoming more and more standard, especially on startups. But we started using this, I think 5 years ago, in putting automatic linting, making sure that we have the processes helping the developers. Another thing is about sharing knowledge. When you start dealing with large teams, Fidzai is now over 200 people. One of the things that is very important is how do you share knowledge? How can you have a product with over 1 million lines of code and engineers know how to deal with it, how to fix it? One thing that is usually I see it also in our recruiting process, engineers appreciating, is that even in our technical challenges, we really like that engineers document their code. This is just a detail, but it makes a huge difference in our onboarding process. It makes a huge difference on how we can move forward with our development process. And we also have our talks at Fidzai, which are basically internal talks. Some of them we open them, or we are starting to open them to the community, but it's a way of different teams sharing their knowledge within the company. Aside from development, I wanted to highlight also the recruiting part. One of the things that we started back in 2009 is to having a recruiting process that at the time was very odd in the market in Portugal. So we started use the technical challenges. It was very common and still today, depending on the candidate availability, that we get engineers working with us for 2-3 days at Fidzai, just as a recruiting process. And one of the most interesting things is that this is very good for us to know the engineers, but mostly engineers get to know us. They know how the company works because they are just embedded for a few days in the company. And if you are at an office of 50, 60 people, and this is happening on a constant basis, it's very hard that you are not showing how the company works. Also about the training on recruiting. This is something also that we have realized that is very important. We are hiring engineers, and after 1 month they are doing recruiting for new engineers. How do we make sure that we get the best talent? How do we make sure that we hold up to our standards? So not only doing training on the technical side, but training on how to recruit, align expectations, how to make sure that we don't defeat the values that our current engineers have. So I didn't want to forget our FIDSI research team. And this is not about these small improvements in innovation that we do, but I didn't want to forget that we also do the to the moon type of research. So our research team has engineers and data scientists from different areas, and it's very common that we rotate from the product team to research, from research to professional services, to share and to allow everyone to have similar opportunities. But here are just a few examples. Algorithms is one of the areas that the team focuses very often. Of course, this also has some impact on the business. But one of the things was that got us really proud of ourselves is this type of algorithms. One of them, finding compromised ATMs and POSs. We have run into our customers' data after building this, and we were able to find a lot of data breaches in the US. So we have simulated as we didn't see the data breaches, but we were able to find most of the data breaches in our customers' data. Another one is a very cool one where we use geographical data to find patterns of fraudsters that are using bulks of credit cards, and they are going to use them in stores, and to allow to not be caught by these type of systems. Basically, they go store by store, and we are able to correlate them by geographical location. The last one that I've chose is about explaining machine learning models for humans. We use extensively random forests models, and this means that we are taking a decision that is built or influenced by hundreds of signals and hundreds of small decisions, binary decisions. So it's very important to show to the customer, and in fact, in some of the areas of fraud management, it's even a regulation need. The regulators don't allow algorithms to operate blindly. You need to explain why you are declining someone transaction. So we are able to explain this type of decisions. So I hope that, well, there was not a lot of people standing their hands saying that enterprise software was boring. I'm not sure if it was really true or just because you didn't want to be bad for me. So with this, I hope that you now look at enterprise software not only at FIDSI, but to any startup, mostly that is trying to build software for large corporations, as places that really can innovate in all areas. And if you are up to the challenge, we are continuously hiring. Don't be afraid. Just come and join us, or just walk around and see how we work. Questions? Anyone has questions? We have a question there. We have still 5 minutes from the organization. Okay.
Just a clue. clarification. When you say that you explain or translate to human speak why some transaction was refused, but I assume that you don't explain too well because you would be helping the perpetrator how to hide his actions.
So the goal is to explain this to our customers. With this, I mean, for example, in Portugal, there is a big fraud prevention center from SIBS, which basically does the fraud prevention for all the banks in Portugal, and they have a team of fraud analysts that. When the system, so there is a trade-off here. Sometimes you really decline the transactions automatically, or you approve them. But because if you decline a good transaction, it can be harmful for the business. There is a small interval where you just send that transaction to be reviewed by an analyst. So in those situations, mostly, you need to help the analyst to understand why the system decided this, because even that the transaction has 50 or 100 fields, we use much more information. So it's very important that we enrich that information and help the analysts to decide. This was really different from the past because these systems were mostly managed, or the systems that were preventing fraud were only using rules. So when you write a rule, it's a human writing it. So there is a clear notion of what the rule is doing. With a machine learning model, it's very different because you are dealing with a statistical model. So anyone else? No one wants to innovate more? All right. I think we are finished. I'll give you 17 minutes back.